We're going to look at energy in rotation. So specifically the kinetic energy when something's rotating and moving is going to have the 1/2 mv squared, but also because it's rotating, I'm going to have 1/2 I omega squared. And in this example, I'm going to start a bowling ball at the top of a 7-meter high hill, and I'm going to roll it down to the bottom. And I want to know how fast is it rolling at the bottom. Now, you'll remember when something's rolling, I do have a relationship between the velocity of the center of mass and the angular velocity of it. And so we're going to use this here to substitute in for omega when we solve this problem. So, energy problem. Starts at point 1, ends at point 2. I'm going to be using the work-kinetic energy theorem. Now, an interesting one here, we don't have any applied force, but we start to talk about work done by friction. Well, there is friction. Otherwise, it wouldn't roll. But there is no work done by friction because there's no sliding between those surfaces. The bowling ball is not sliding, it's rolling. And so there's no work done by friction because there's no displacement between my surfaces. There is kinetic energy at the bottom of the hill, and there's both types, translational and rotational. It starts at rest at the top. At the bottom, its height is 0, and there's no springs. So when I rewrite my equation here, I have 0 is equal to K2 minus UG1. And I'm going to make my substitutions. I'll move the UG over to the other side, so I have MGH. That's the same as before. But now when I talk about kinetic energy, I'm going to talk about 1/2 mv squared plus 1/2 I omega squared. Whenever we do this, we're going to do a simple substitution for I and omega. I, we're going to get off our sheet. So a bowling ball is a solid sphere. The one we're looking at here is. And so for that one, I'm going to use an I value of 2/5 mr squared. And instead of omega, I'm going to do v over r. And it's omega squared, so it's going to be v squared over r squared. And you're going to see why we want to do this as soon as we write it out, because now my r squareds cancel. My m's also cancel. And so I have GH is equal to 1/2 v squared plus 1/5 v squared. And 1/2 plus 1/5 is going to be 7/10 v squared. And so I can solve for v. And so v is going to be 10/7 GH. And I can plug in my information that the height was 7 meters and g is 9.8. And I will find out that it's moving 9.9 meters per second at the bottom. That's about as fast as a person can sprint.